Okay, so welcome back. This is week three's tutorials that I'm doing for you. I will be uploading them in probably two parts to keep them smaller. As you probably noticed, they're on YouTube now, so that you can always just search for it if you ever forget where it is. Today we're going to continue from what we did before. So last week we did both. Let me show you both scenes that we did. We continued from our class setup where we had the character. We made him run, made him jump. Okay, and what you've probably noticed is I'm just going to show you how I did the camera follow with a little bit of lerping, so that we can just have a little bit of a lag or delay behind the character. And then after that we did the isometric or top-down controller setup. And if you've done it correctly, you should have something like mine over here. There we go. And now the only issue that I have, other than the fact that I've only got 4 quadrants, I've got a up animation, right animation, left, and down. So I don't have all 8 quadrants. So when I have 8 quadrants, we can just go over how to set that up. But it's extremely simple, and it's done inside the animate itself. Now, then what we're going to continue on today is, if I run right, I want him to be looking right when I let go of the button. If I run up, he looks up. When I run down, he looks down. But right now, he's always going back to his default idle position, which is, depending on the one that you've chosen, mine was just away from the camera. So we want to set that up. So let's talk about how I did the camera really quickly. I won't do it all over again. I'm just going to walk you through it, and then I'll move on to the actual animations for this week. So as we do, what I normally do here is I set up an object that's by the character, empty game object, call it camera base, and then I put my camera as a child of that, so that the character and the camera are in the same pivot location or same origin. Now on the camera itself, we can just see I've got 2 variables. I've got one referencing the player and another one referencing the lerp speed for which the animation will interpolate. So the higher the number, the quicker the camera will follow. The lower the number, the slower the camera will follow. And the code is extremely simple. That's why I'm not recreating this again. It's all plugged into the update. I'm using a vector 3. Let me just zoom out so you can see it, because Bolt's got a bug where if you zoom in, it breaks the text on the actual node. It's a vector3.lerp. So if you right click and you go vector3 lerp, you'll find that there's a vector3 lerp. You've got an slerp, you've also got an unclapped one, and you've got an unclapped lerp. We'll talk about those as we go, but right now you can use the standard lerp. So when you do that, let's talk about this node. A is the position the camera is currently at. So in this case, I got the position of the camera. So I told it transform position get, and it's just in relation to itself. That is the starting position, and the end position is that of the player. That's why if we look at our variables, I made a reference to the player. So I created that variable, I dragged the player into there so that I have a reference to the player. And over here, I just grabbed the variable in. I did a transform position get, and I plugged that into the B. And then the time, or the T, is how long it's going to take for it to catch up or interpolate. So what I do is, like what we do in code, is just for safety's sakes, I added a time, delta time. So right click and say time dot delta time. You get a get, and then you're going to multiply that by the variable that I created called lerp speed. So if I go on the right side here and I go to object, it's that float that I created. So I would just drag this lerp speed in and multiply that. Again, remember, we're multiplying it to speed it up or slow it down, exactly the way we did the character movement we're doing with the camera interpolating. And when you're done with that, you just plug that directly into the time, and then it will set it up. Now once you've done all of that, it's simple, it is done, but now we actually have to tell the object, in this case the camera, to do the actual movement. Because right now we're just creating, remember, you're just creating a vector, a lerp vector, which then needs to be set to something. So all we do is drag from here, we do a transform position set, we're setting the camera to the new vector so we drag out from the new lerp vector into the position vector, and then that's it. That is the code. And let's talk about the speed that's setting here so you can see it in action. So if I were to put this value down to something like 0.5, as you see, when I start running, the camera takes quite a while to catch up. But if I put that to something like 5, it's almost instantaneous. You'll see there's a little bit of follow through at the end. And if I make it even faster, something like, at some point, once you get too fast, then it makes no difference. There we go. 15 is pretty much almost one-to-one with my movement. So that is nice. It's just a nice little feature to have to control the amount of, just kind of makes the camera a little more dynamic as well. So just keep that in mind. That is a really nice thing to do. Even as little as mine is right now, you can kind of sense it, especially when the jump. You'll see the character almost leaves the frame before the camera catches up. So that's quite nice. I'm probably going to put mine somewhere between the two, so I'm going to go about 3.5. Okay, so that's it for the 2D side scroller. We'll come back to both of them when we create a health system. But right now, I just want to finish off the top-down game. Now, again, just to talk through what we've done here, we're going to go to the animator just to show you the animator. All we had in the animator was this four-way locomotion. So we had an idle, a run top, run down, run right, and then I used a run right again because I didn't have a run left from the sprite sheet that I got. So all I did was mirror this animation or flip this animation in the player itself using the flip X inside of the sprite renderer. So keep that in mind because that's what we've got here. Now before we can actually get the whole system working is we're going to kind of semi-break this and create it again. So we'll need to have this, and then we're going to recreate it, another one. So I'm just going to go and say right click, create state empty, and we're going to call this one idle state. Yeah, just call it idle. Actually, idle state is good. We'll just call it idle state, and we're going to right click on this state and make this, set this as the default layer state. Now all the animations will stop working because we've essentially bypassed all of these variables we created in the last video. So now the character will move around, but he will no longer play his animations. He's got nothing assigned to him. Okay, so I'm going to quickly go in here. We're going to set up the little blend tree, and then from there we will go and just quickly create the animation. So inside in this animation, right click and say create new blend tree and state. Remember to double click on the state so you can see the blend tree. And we need to create 2 new floats and 1 boolean. So I'm going to create my first float, call it x idle. I'll create another float, z idle. I'm sure there are better ways to do this. In the short time that I had to set up this tutorial, this is the quickest way I could think of getting this to work with the least amount of effort and it's pretty hassle free. I'm going to add a boolean like I said earlier on, and this one's going to be moving. So I want to know if it's moving. If it is moving, I want to be able to move out of this state into the movement state. So now that we got this, remember, 2 ways to add a new motion. Either click on the little plus up here and say add motion field, or just right click on the state, say add motion, add motion, add motion. We only need 4, 1 for each direction. We're going to have for the different idles, like idle top, down, left, right, or right, left, up to you how you want to set it up. So we're going to do those, and then we will come back to this. But first I need to make this a 2D Cartesian. Remember that? And the first one's going to be x idle, and the next one's going to be z idle. So we're using those 2 new variables we created. So let's just set these variables up. So x I'm going to use as the actual x in the graph, and z will be the y in the graph. So over here it's going to be if I'm going up, that's going to be 0 in the x, 1 in the y, and if it's going to be down, it's going to be 0 in the x, minus 1 in the y, and if it's going to be right, it's going to be 1 in the x and 0 in the y, and then if it's going to be left, it's going to be minus 1 and 0 in the y, just so you can get that nice little plus sign kind of where the animations are. And when we add them in, you'll see it in the little animation view in the bottom right playing. So I've got my animation window open at the bottom here. If you forgot how to do it, I'm just going to close this one. Go to Window, Animation, and Animation Window. Okay, and I'm just going to dock it wherever. I'm going to put it back where I had it originally. I'm going to select my character. I'm going to go and create a new animation clip. Remember, I created an animations folder, and I created a TD folder for top down, and I'm going to, now that I do have an idle top, but I'm going to, actually no, I'm going to leave that. I'm going to create another one called idle down. So we're going to create an idle down animation. I'm going to go down to my little sprites. Remember, we had sprite sheet for this. And I'm just going to kind of cycle through all of them till I find the one that kind of looks like it's looking down. There we go. That's nice. I'm not even going to try to grab multiples. I'm just going to grab one, drag it into here, copy, and I'm going to paste it like 30 frames later. All I need is just that pose there. And then I'm going to right click, create new clip. I'm going to call this idle right, and unfortunately I think I only have right, so I'm going to use my right for both my right and my left again. So I'm just going to find it now. That's down. That looks like it. Idle right, there we go. I even named it. So I'm going to grab the idle right, drag it into here, Control C, and go about 30 frames in, Control V, and I have my idle right. So I've got my idle down, top and right, and like I said, I'm just going to repurpose my right for my left as well. Okay, so now that we've done all the animations, we're good to go back to the animator and plug all of these animations in. I'm going to navigate to the folder where the animations are, select the character, select the blend tree, and start by going idle top, and I think we did idle down, idle right, and then idle right again. So it makes no difference. In this case, it's going to look the same. So if I just scrub through this here, you'll see as I go to the top, to the right, to the bottom, to the left. And remember, the left and the right will actually flip using the flip X, so those two will be fine. So based on where he stops moving, we're going to get the direction that he's going to stop and look at. This is just, it's something simple. You don't have to necessarily do it, but it's something I like adding. Just adds a little more to your game. Ooh, don't delete the locomotion. Okay, so now that we have that, I'm just going to move all of these states to the side. Just neaten this stuff up a little bit. Okay, so from here, I'm going to right click, make transition, and this transition state, this line, remember, it is a condition. We need to have a condition here. First of all, I'm going to remove has exit time, and I'm going to hit this little plus to add a condition, and we created a condition called moving. So if moving is true, go into that state, right click on four-way loco, go down, and you now have two lines, one going from idle state and one going from the movement state down. So on this, I never like using has exit time unless I want there to be a delay between my inputs on my animations, or there's an animation that I want to play completely before the input can take over. So I'm going to turn off has exit time. I'm going to add the condition moving, and I'm going to set that to false. Now I'm going to leave all the settings here as default so I can show you the issue we're going to have, and then I'll come back and we're going to have to tweak that for it to work. Now again, we start the game now. We can look at the locomotion. I'm going to just make sure I have it selected. We never leave that state, but if I turn moving on, we do leave that state. So we now need to go and set up the code for all of this to work. So let's go do that. So basically the animator is done with one setting that needs to be tweaked, but we're just going to go back to the flow graph. Let's talk about what we did the last class. We just got the horizontal and the vertical axes. We multiplied that both by player speed, and then we fed that into a new vector 3, and then we set the velocity of that character. And then we just set the animator floats to play the animations, and then we did a condition check to see if it is greater than 0, leave the sprite sheet flip X off, and if it's less than, then flip the sprite sheet. That's all we did there. Now we're going to add a new section here. I'm going to drag from here and type in sequence, and I like using sequences just to keep things neater and get them out of the way so that not everything is in the way. So I'm just going to pull this out because essentially that's not part of this system. Okay, and let me just make sure everything is working, and then from here we're going to drag out and create a branch because we want to do a check before for something before we do anything else. This is where we're going to play and set up all the different directional positions for the idles, not for the movement. This is where the movement is, as we can see here. Let me just color code it. We'll make green for movement. We'll make the flipping, we'll make that like a blue, just so that we can see that that's sprite flipping. That's what it's called. And then this one down here we're going to create is going to be just for the idle and the controlling of the idle. So now there are a few things we need to know. And all I'm going to do is just basically copy these to you, just so that they're all on camera so I don't have to zoom out. All I did was copy the input horizontal and input vertical, just so I can do a check on this. Now you can just drag it from the top here. I'm just doing this so that you can see it better on screen. Excuse me. Okay. Now, I need to know if the culmination or the total of these two values is greater or less than 0. It needs to tell the character that it's moving so that it can play the moving animation. If it is not, it needs to tell the character you stop moving, and the last input value was this. Use this to drive your blend tree for your idle. So let's just, the way you do this is simple. Hold on. We need to drag, right click and add a new vector 2, because that's all I need. I need a new vector 2, and I need to have the exposed values. So I need this horizontal as x, vertical as y. I need those two values as a vector 2 so that I can do drag off this, and I'm going to be looking for the magnitude. So magnitude, there we go. Now a magnitude value is basically a hold on, let me just let's just use a normal magnitude A. That should be fine. Okay, so what this is going to do is going to give me one output value from these two inputs. So if this is 1 and that is 0, this will still come out as 1. If this is 1 and this is 1, this will still come out as 1, so on and so forth. So it will always give me the value of these two as a combined output. Now from here I can drag this out, and I can go equal, or in this case, yeah, we can say equal, just break this, go to float. Now we might need to use a vector. I'm just trying something gutsy here at this point. So if it is equal to 0, then do nothing. Well, not nothing, but basically it's going to say that there's a few things it needs to do. So if these are equal, then it's not technically moving. If it is, then move. So we're going to do like we did in class, we're going to do a animator dot, and this time it's a set bool. We need the item name and the value. So we know the name, I think I called it moving, and it is on this object, the character. So if he's not moving, then I want that to be false. Control C, Control V. If he is moving, I want that to be true. So let's test that system as it stands to see if we can get it to leave this state and move into the animations. Because remember before, when we broke the system in order to add the idling, the animation didn't work. So we're now there, and now we're walking, and the animation walking works. Okay, there's a little bit of a delay there, a little freeze that I'm not happy about, but I will probably tweak that now. So now the system is working. Now we need to just do a few things. We need to actually change the direction in which he idles. So I'm going to put these right at the front and just leave them there so we don't forget them. Now I need to make some temporary variables that I can use later on. So what I mean by that is I'm going to go to object, and I'm going to create, oh wait, I've already got them created, so I'm going to remove them. I'm going to create a new variable called xidle that matches the one inside of the animator, and I'm going to create another one called zidle. Remember, both of these need to be floats, and they both can be set the way they are. So first thing first, when we're moving, we want to set this value both for X and Z. Plug both of those in, and where we're going to get those values are simple. We're getting them from the horizontal, which is going to go into my X, and the vertical, which is going to go into my Z. That's it for the movement. So when it's moving, it's going to calculate what that input is so that we can feed that into the animator, and then we should be good to go. Now, what that means is we're going to then feed that back in, apologies, into the animator itself. So now we need to, instead of doing a set animator bool, we need to do a animator set float. We're going to use two of them. Remember, one is called X idle. I'm going to Control C, Control V, and the other one's called Z idle. Remember, naming is important. If you named it with uppercase, lowercase, whatever it is that you named it, keep in mind that naming needs to remain the same. So now remember this X idle that I had. I'm going to use that into my X idle, and my Z idle I'm going to drag in and use into my Z idle value. Now, as it stands, this should work. There will be a few glitches. That's why I said we're going to go back to the animator and make sure it is done correctly. Why are you still orange? Your values are correct. Your names are correct. Okay, so let's just double check if this works. So I'm going to go to the animator, and in the idle state, I just don't want any weird conflicts or any weird issues. So these values here in the idles, I'm going to make them really small values, like let's say 0.1, minus 0.1, 0.1, and minus 0.1. Reason for this is sometimes the animation, these values might update a little late when it's changing between whether it's equal to or not, and then you get some really weird values here. Trust me. Now I'm going to show you this should work, and then you'll see the glitch I'm talking about. If I go up, as I suspected, I am getting an error somewhere. Quite sure we have an animator here. Wait too. Sorry about this, guys. I'm having some weird, well, not weird, but an interesting glitch. So I'm just copying from a working set float. Hold on. Are my variables null? Of course they are. Of course they are. I'm quite sure there were floats early on, but okay. I'm not gonna fight this. It was X idle. Paste this again and go. Call this one Z idle. Okay, now that should work. Sorry about that. Again, like I said, I'm quite sure I set those two floats, or at least they would look like they were floats early on. Let's see. Okay, so notice how when I run left, it works, but there's a moment where he goes to the original top position before coming to the idle stand. Do you see how that little pop is? Except for the top, because, okay, so we need to fix that. So let's just go into our animator, make sure we've cleared out any. So four-way locomotion, first let's remove the idle top here. We do not need that animation there because we're not idling anymore in this movement. We're only getting the run top, run down, run right, run left. So let's test that again. You will notice that the bug is still there, but it's a lot less prominent. So we're going to just refine the blending between these layers. So if you go to the state going from the movement down, we're going to open up these settings and we're going to play around with these two. This is the end of the stage, so transition offset, And the one we're going to mess with is the transition duration, how long it takes to blend. I'm going to put 0 for the blending. It won't always work, but in this case it works fine. You'll see it now when I go to the right. No more snapping, no more snapping, no more snapping, no more snapping. There we go. So now he stops, looks in the direction he's going, and that is cool. So like I said, if you probably find as the year goes better ways to do it, I'm more than willing to hear them out. I think it's going to be awesome to figure out some cleaner ideas in this. Like I said, this was just the quickest, nicest possible way that I could think of without completely like over engineering something as simple as just having an idle state. So let's call this idle state. So we got our movement. I'm going to call this movement state. Just keep it all nice and wordy. Movement state, and then flips, and then we're going to just give this a color of something like orangey color. Okay, so let's go through this one more time before this video is over, and we'll come back for the next video. All I did was I got the input get access for horizontal, input get access for vertical. Remember, these are names I typed in. Do not search for horizontal or vertical, you will not find it. And then I created a new vector 2 from these two inputs. One, the horizontal went into the x, because remember horizontal is left to right, and then vertical is up and down, which is y, so I plug that into the y. And then the magnitude, like I've said, is the total value. The total value with the incorrect use of it is the culmination of these two, like the almost like the square root, if you will, of these two values. And then I get one value that I compare to 0. If it is equal to 0, then all I'm saying is the character is not moving anymore in the animator, so play the idle animations, and I'm setting these animations based on the last time we updated these two variables while the character was moving. So when we're moving, all we're doing here is we're saying take this value, which is between -1 and 1, and put it and store that into this variable. Once it's stored, use it when we're idling. So what I mean by that, let me just actually try to show you a case on the right side here. If you look at the right here where the variables are, we might get lucky and be able to see it. Notice how when I go right, that value is 1, -1. When I stop, the value gets clamped really, really close to 0, 0.01. That's why I made that value in the animator so low. And then when I go that side, the value gets saved and gets used up here. So if we wanted to be 100% safe, we could probably just use a better system than this. The get access has a value that lerps from 0 to 1 and 1 to 0. So that's why we get this little delay before the actual stopping. It's not it's not the longest lerp, but it's enough to make this value go really close to 1, depending on how. You'll see it's an inconsistent value, but we get the result we want. That's why I put the value in the animator to be really low. There we go. That works really nicely. That's it pretty much. I'm going to do another video after this. I will be back in just a little bit. But keep in mind, we also did the camera setup earlier on, and we did the top-down movement. So next is doing some sort of system management, health, coin pickups, that sort of thing. We'll do that. One system that you can use for both, pretty much any game you want. So be back in a little bit. Thanks, guys.